Real production data is messy, large, and easy for a model to drown in. In this module, we'll design MCP tools that return just enough searchable, filterable, paginated results that protect systems while keeping exploration productive. So far, we've built the foundation for production MCP servers, added secure access patterns, and defined reliable tool interfaces. Now the challenge is scale. Returning enough data to be useful without overwhelming the model, the user, or the system. In production, an MCP tool often connects to real systems with huge tables, not toy datasets. If a request can return everything, the impact spreads quickly. The model's context fills with irrelevant records, and reasoning gets worse. The database may work too hard, causing timeouts, retries, or cascading failures. Every extra row also increases the chance of exposing data the user did not need. A production tool should be conservative by default. Filter, limit, summarize, and return the smallest result that still supports the next action. Result size should never be accidental. Start with conservative defaults, such as returning 20 items when the client does not specify a limit. Then enforce a maximum, even if the client asks for more. Also, cap total payload size and stop before responses become slow, expensive, or unsafe. The key is to make truncation explicit. Return fields like has more, next cursor, or a clear limit warning so the client knows what happened and how to continue. Result budgeting is part of the tool contract, not a hidden backend choice. Pagination makes repeated calls predictable. Offset pagination says, skip the first 100 records and give me 5. It is easy to implement and debug, but it can become expensive as offsets grow. It can also miss or duplicate records if data changes between requests. Cursor pagination says, continue after this stable point. The token hides the ordering details while improving performance and consistency. For production, MCP tools over business records prefer cursors. Use offsets mainly for small, static, or admin-only datasets. Reliable pagination starts with one promise. Every request uses the same deterministic ordering. Sorting by created at alone is not enough, because two records can share the same timestamp. Add a unique tiebreaker, such as ID, so each record has one exact place in the sequence. The continuation token captures where the previous page ended, along with filters and sort values. Keep that token opaque. Clients should not edit it or depend on its structure. Sign and validate it server-side, and consider expiry, so pagination can resume safely without leaks or tampering. A pagination-friendly schema removes guesswork for both the server and the model. The request should make page size explicit with a limit, while the server still enforces a maximum. The cursor is optional on the first call, then treated as an opaque token on the next call. Sort and filter options should be controlled, not open-ended. The response should include the items, a next cursor, has more, and often result count. Those fields tell the client whether to continue, without relying on prose or interpretation. Filtering is powerful because it narrows results to what the model actually needs. But the tool should never accept an open-ended database query. Define a safe filter contract instead. Choose which fields are filterable, which operators are allowed, and what types, ranges, and enum values are valid. Put hard limits on filter count and date range size, so one request cannot trigger a massive historical scan. If the user asks for raw SQL, a custom DSL, or an unsupported operator, reject it clearly. Safety comes from constrained intent, not clever parsing. Tenant or account values supplied by the client are input, not authority. The server derives the real tenant, user, and scope from authenticated context, then applies policy before building the query. A requested tenant ID override should be ignored or blocked, not merged into the final filter. Apply these constraints before pagination, sorting, and result shaping, so unauthorized rows never enter the result set. For sensitive tools, log both the original intent and the effective constraints used. Search and filtering may look similar, but they answer different questions. A filtered list tool like list tickets handles exact structured constraints: status, owner, tenant, type, or date range. Its behavior should be predictable and easy to authorize. A search tool like search tickets supports discovery through keywords, natural language, and matches across text fields. Because search is relevance-based, return ranking signals carefully, such as matched fields or short excerpts, not unnecessary internals. Keep limits tight as well. Broad search can become noisy, expensive, and harder to secure. Good search output is not a pile of documents. It is a set of compact decision cards. Each result should tell the model what it is, why it matched, how fresh it is, who owns it, and whether it is worth opening. Short snippets are especially useful because they let the model compare evidence before spending another tool call. Relevance scores can help with ranking, but avoid exposing noisy internal formulas. Most importantly, every result needs a stable identifier. The model can pass into a detail, investigate, or follow-up action. More data is not automatically better. The goal is to give the model just enough signal to decide what to do next. For discovery, return compact summaries, stable identifiers, short excerpts, and links. If the model selects an item, a separate detail tool can retrieve the richer record. Full exports or large nested objects should be reserved for explicit requests. This pattern protects the context window, reduces confusion, and makes tool use more reliable because each response matches the decision the model is trying to make. Think of large results as a funnel, not a dump. Start with a list or search tool that returns compact candidates, names, dates, status, and a stable ID. Then let the model choose one candidate and call a detail tool, such as list orders followed by get order. The detail response can include recommended next actions, like fetch shipment, issue refund, or open customer history. Keep expensive operations separate. Full document retrieval, exports, and reports should require explicit follow-up calls. This stage design reduces token waste, avoids repeated broad searches, and keeps decisions grounded. When a request may return a huge dataset, do not stream everything back synchronously. Treat it as a controlled job. First, validate the user, policy, scope, and rate limits. Then create an export job and return a job ID, progress status, and estimated completion time. A background worker builds the artifact, stores it securely, and exposes only a signed, scoped link with an expiry. Before release, provide previews or summaries so users can confirm the result. Finally, audit every step, because generated files are data products too. The core lesson is simple. Production. MCP data tools must be bounded, safe, stable, and useful. Set clear limits and continuation tokens. Use cursor pagination with reliable ordering. Validate filters and search against policy and tenant boundaries. Return concise results that guide the next action. Next, we'll test these choices under scale, edge cases, permissions, and failures.